Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll find the derivative of these functions using product and chain rules. So we have to find the derivative of these three functions. So let's start with the one on the left side. So the given function is f at x equals x plus 4 exponent 3 times x minus 3 exponent 6. So the first step here is to use the product rule because this function is made up of two functions. The first one is x plus 4 exponent 3 and it is being multiplied to the other function x minus 3 exponent 6. So the first step is prime of f at x equals, so we start with the derivative of the first function, and for that we'll have to use the chain rule. So this function is made up of the inner function x plus 4 and the outer function is the exponential function with exponent 3. So we start with the derivative of the outer function. So we'll use the power rule. So we'll move the exponent 3 to the front and then times x plus 4, the inner function, exponent 3 minus 1. So we subtract 1 from the exponent times the derivative of the inner function, so which will be 1 because 4 is a constant, so its derivative is equal to 0, and then times the second function plus, now the first function times the derivative of the second function. So again we'll use chain rule. So we start with the derivative of the outer function, and for that we'll use the power rule. So it will be 6 and then x minus 3 and exponent 6 minus 1 times the derivative of the inner function, which will be just 1. Now we can simplify this expression. So prime of f at x equals, so now 3 times 1 is equal to just 3. So we get 3 parentheses x plus 4 squared and then x minus 3 exponent 6, then plus, now here we do 6 times 1 which is 6, and then x plus 4 exponent 3 and then x minus 3 exponent 5. Now we can simplify this expression by doing common factoring. So from these two terms, so first we can common factor 3, then we can common factor x plus 4 squared, and then we can common factor x minus 3 exponent 5. And now we are left with x minus 3 from the first term, because the first term has x minus 3 exponent 6, and from the second term we are left with 2 and then parentheses x plus 4. Now we can simplify this expression, so we'll distribute the 2 into the parentheses. So we get prime of f of x equals 3 parentheses x plus 4 squared, then x minus 3 exponent 5, and then we get x minus 3 plus 2x plus 8. Now we can combine like terms in the last parentheses to get the final answer for the derivative of this function. So we can start with 3, and now we can write the last parentheses first because in that parentheses the exponent of x is only 1. So we get 3x plus 5. And now we write the other 2 parentheses, so x plus 4 squared times x minus 3 exponent 5. So this should be the final answer for the derivative of the first function. Now we can find the derivative of the second function. So I'll use the red color for that. Now the second function is given as y equals x squared plus 3 exponent 3 times x cubed plus 3 exponent 2. So for this function, we again have to start with product rule because it's made up of two functions being multiplied. The first function is x squared plus 3 exponent 3, and then the other function is x cubed plus 3 exponent 2. So I'll start here at the bottom. So our first step is to y prime. So I'm using the prime notation. So the derivative of the first function, and for that we'll use the chain rule. So the inner function is x squared plus 3 and the outer function is the exponential function exponent 3. So for the outer function, we'll use the power rule. So we get 3 and then parentheses x squared plus 3. So we move the exponent to the front and then we subtract 1 from the exponent times the derivative of the inner function. And the derivative of the inner function will be just 2x. So the derivative of x squared is 2x, and since 3 is a constant, its derivative will be equal to 0 times the second function, so x cubed plus 3 squared, and then plus the first function x squared plus 3 cubed times the derivative of the second function. So again we'll use chain rule. So we'll start with the outer function, which is the exponential function. So we'll move the 2 exponent to the front and subtract 1 from the exponent. So 2 minus 1 and then times the derivative of the inner function. So derivative of x cubed is 3x squared, and for 3 it will be 0, so we can ignore that. Now we can simplify this expression. So in the first part we can multiply 3 by 2x, so we get 6x, and then parentheses x squared plus 3 exponent 2, and then x cubed plus 3 exponent 2. Now in the second part we can multiply 2 and 3x squared, so we get plus 6x squared, and then x squared plus 3 cubed, and then x cubed plus 3, and here the exponent is just 1, so we don't have to write that exponent. Now we can simplify this expression by doing common factoring. So from these two terms we can factor out, so y prime equals, so we can factor out 6x, and then we can factor out x squared plus 3 squared, and we can factor out x squared plus 3. And now we can write what's left over. So from the first term, we'll be left with just x. Sorry, no, it's not x squared, x cubed plus 3. So from the first part, we are left with x cubed plus 3 plus x, parentheses, x squared plus 3. So there's a very tricky step because of the terms are a bit confusing, right? So we have to be very careful when we do common factoring for a step like this one. So now we can simplify the terms in the parentheses. So now we can move here. So we get y prime equals 6x, then x squared plus 3 squared, and then x cubed plus 3. Now in the parentheses we can distribute the x into the parentheses. So we have x cubed plus 3 plus x cubed plus 3x. So there is a very important step you need to understand and memorize. Now we can combine like terms in this last parentheses. So we get 6x times x squared plus 3 squared, then x cubed plus 3, and then 2x cubed plus 3x plus 3. So we combine the like terms. So x cubed plus x cubed, which is 2x cubed, and then 3x plus 3 stay the same, and we arrange them in the descending order of exponents of x. So this should be the final answer for the derivative of the second function. Now we can find the derivative of the third function. So I'll use a different color for that. Now this function is the third function is a rational function. Now in order to simplify it, so we can use the quotient rule, or the other option is to use the product rule and chain rules. So if you want to use the product and chain rule for this expression, so the first step is to move the denominator to the numerator by making the exponent on it negative. Now the exponent on the denominator, in this case x squared plus 1, is just positive 1. We don't write 1 as an exponent. So the first step is to move the denominator to the numerator. So we'll get 3x squared plus 2x times x squared plus 1, and then exponent negative 1. Now we can use product rule because now this function is made up of two functions that are being multiplied. So we start with the first function. So the derivative of the first function is the 6x plus 2 times the second function, so x squared plus 1 exponent negative 1, and then plus the first function 3x squared plus 2x. Now for the second function derivative, we'll have to use chain rule because there is an inner function x squared plus 1 and then the outer function with the exponent negative 1. So we start with the derivative of the outer function. So the exponent negative 1 comes to the front, and then x squared plus 1, and we subtract 1 from the exponent times the derivative of the inner function, which will be just 2x. So the derivative of x squared is 2x, and 1 is a constant, so its derivative is 0. Now we can simplify this expression. So in the first part, we can move x squared plus 1 to the denominator because its exponent is negative. So we get 6x plus 2 over x squared plus 1. We don't have to write 1 as an exponent. Now in the second part, so we can multiply negative 1 by 2x, so we get negative 2x. So we get negative 2x and then 3x squared plus 2x, and the exponent of x squared plus 1 is negative 2, so we can move that to the denominator. So we'll have x squared plus 1 squared in the denominator. Now we can simplify this expression. by combining these fractions, and for that we have to find a common denominator. So we'll multiply the first fraction in the numerator and the denominator by x squared plus 1, because the common denominator here is x squared plus 1 square. So I'll multiply the numerator by x squared plus 1, and I'll multiply the denominator by x squared plus 1. So the next step is, so y prime equals, so in the numerator we'll get 6x plus 2 times x squared plus 1, and then in the next part it will just be negative 2x, and then 3x squared plus 2x over x squared plus 1 square. So because we have a common denominator now, we can combine the fractions. Now we have to simplify the numerator. So for the first part, we'll have to distribute the terms in the parentheses using the FOIL method. So we'll multiply 6x by x squared, and then 6x by 1, and then 2 with x squared, and then 2 times 1. So I can start here. So I get y prime equals, so we get 6x cubed plus 6x, because 6x times 1 is 6x, and then plus 2x squared plus 2. Now in the second part we can distribute negative 2x into the parentheses. So we get negative 6x cubed negative 4x squared over x squared plus 1 squared. Now we can combine like terms in the numerator. So 6x cubed and negative 6x cubed cancel each other out. And we can combine 2x squared and negative 4x squared. So we get y prime equals, so 2x squared minus 4x squared is equal to negative 2x squared, and then plus 6x plus 2 over x squared plus 1 square. So this should be the final answer for the derivative of this third function. Now we can also factor out a negative 2 if you want from the numerator to show it in the factored form, or you can keep the expression like this and it should be fine. So these are the steps you have to keep in mind to find the derivative of these types of functions. So these functions are complicated, so you have to be very careful when you are applying product rule and chain rule to find the derivative. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.